talk about Azure, StorSimple. Okay, cool. So let's deep dive. So my name is Jai Desai. I'm the worldwide technical solution professional here at Microsoft. Came through the acquisition of StorSimple, and happy to be here. It's my first MMS, and it totally psyched about it. So I'm going to talk about couple of points on Azure, and then deep dive into StorSimple, right? What are the capabilities of StorSimple, and how can you start leveraging Azure within your data center? So really brief agenda, because I really want to jump into a live demo of StorSimple and how it integrates with Azure also. So just a few points on Azure, then jump into what is truly StorSimple, right? How do we enable that whole cloud integrated storage that everybody's talking about, and give you much more capabilities around backup, DR, archiving, all that within a single solution. And then jump into how do we do it. With that, let me jump into Windows Azure. You've attended multiple sessions already. I do want to realize what is Azure, but the most common question that I got when I was at StorSimple was, where is your data center? How many data centers do you guys have, right? As a StorSimple team, we never had a data center, right? We were not the cloud platform providers. Our best partner was Azure. Azure is a truly enterprise-class cloud platform that allows you to deploy, manage, and build out your infrastructure, or you can manage your applications in Azure. What are the services that Azure provides in its data center, right? This is what the typical infrastructure has been, right? You have everything from applications, data, networking being managed within your infrastructure. You have application teams, you have storage team, you have networking teams, right? What is happening now with sort of infrastructure as a service, platform as a service, software as a service coming in, you can decide I really want to maintain just application and data, or I really want to manage the OS level capabilities also on the virtual environments that I am going and renting out, or that Azure allows me to go and rent and build my applications on top of that. So it lets you get into this model of how much control, depending on the application, do I want to manage and maintain within my infrastructure, or I do want to move and migrate into the Azure framework. So you have these capabilities on what to keep internal, or go out all out into the Azure platform if needed be. What are the typical workloads we have seen being migrated into Azure, right? So there is this test dev environments, right? On and off. I go rent out a particular virtual machine, I build my applications or my test farms, I finish my application testing, power off the virtual machine, and be done with it, right? Data set that is growing fast, right? I see tons of file share data or archival data set that I really need to have. I'm not confident on tape. Tapes are unreliable now. Probably during disaster, I might not be able to have access to my tape infrastructure. I could easily migrate those applications and run off Azure if needed be. Unpredictable bursting, right? Super Bowl Sunday, there's some coupon out there. Everybody's going to order using that, and most of these customers basically see a tremendous spike during that 1 hour or during those 3 hours, right? And they can't keep managing and maintaining the infrastructure because it's the fear of unknown. It could have a tremendous burst, and they might not be ready for that, and they might lose out millions of dollars because of not the right infrastructure around that. And there is predictable bursting. So what we are seeing happening is things like data mining, data analysis, data reporting, where on a quarterly basis, I need to generate sales report, or I need to have this legal medical report created. All those predictable workloads are now you can migrate off into Azure and run off that environment. There are 8 data centers across the globe, and think about they are in a paired framework where there are 4 in US and 4 sort of in the European and the APAC region. And it's sort of the matching is east supports the west, and sort of north supports the south in terms of disaster recovery. So data going to this West Coast Azure data center, you can or decide to have the capability to have the geo-enabled replica residing on the East Coast data center if you decide to. And there are multiple CDN nodes, which lets us cover almost every country out there, and you can go and access Azure from there on. With that, let me jump into what StorSimple is, right? On what is happening and why StorSimple is such a key component for Azure. Most of the customers, right, I've been doing storage for a while now, they have either two or all of these storage components in their enterprise. They have a primary storage, they need to replicate it for a short-term recovery purposes, and then long-term archival or compliance reasons. So they either rely on tape infrastructure or some geo-resilient location, right? What is this causing, right? There's equipment sprawl, infrastructure management, and unreliable tapes is what most of my enterprise customers have been talking about on trying to eliminate tape. So what are they starting to think is there some way to offload big file share, big archival data set? Can I replace tape? I need to implement disaster recovery in my environment. How can I leverage that? Or most of these customers are like, cloud is a new concept. What is my first step that I can take and migrate some data off into Azure and still maintain full control around it? When we talk about cloud, right, there are sort of three key concerns that we have seen that come up, right? And this is the slide that summarizes is why are customers not looking to migrating all out into a cloud provider, right? Key concern, security, top of the mind for every CIO, CTO out there, right? Is my data secure? Is it encrypted? Can I get audit logs? Can I integrate into my role-based access control? Are the typical questions that come around security. Then performance. What is the latency going to be like when I'm directly going into Azure and accessing my data set? How fast can I retrieve data, or how fast will I be able to move that data into Azure? And the most important one is sort of the integration standpoint. Do I need a development team to change my applications to directly integrate into the cloud providers? Because Azure sort of talks what we call as the REST API. So they might need application translation happening, or they need to build out their own dev team such that the application can now directly integrate into Azure, depending on the application they're trying to migrate. To minimize the infrastructure growth and directly start and help customers start leveraging Azure is where StorSimple comes in. It is an iSCSI SAN sitting in customer's data center. This storage solution does not reside in Azure data center. This is residing in customer's premise closer to the application, right? So the application server connects to StorSimple via iSCSI. It has enough local capacity to guarantee the performance the application or user needs. The key value proposition starts building from the second block where it mentions the automated cloud as a tier. If and when the local capacity on that StorSimple solution is completely full, we start tiering older blocks into Azure. So that is where we leverage the storage component of Azure and start migrating those untouched or cold data into Azure. From a user or application standpoint, they are still going to that F drive, J drive, or the file share that they've been used to, and all this data migration or the archival movement is happening fully transparent, right? And this is done based on block ranking, which I'll touch upon in a few slides. Now we are saying for certain workloads, this could be tier 1 storage, or this could be tier 1 storage for archival data set, file share, and a couple of these applications. Do I need to have my backup software? Do I still need to rely on tapes? We do provide, within the solution itself, we provide local snapshots which are residing on the hardware. which lets you do single file level restore and things like that. Basically, you could do granular restores. And at the same time, we do allow what we call is cloud snapshots. In the current environment, you might be doing disk to disk replication. Now we are saying, let us help you do disk to cloud replication. This way, you're not tied to your secondary infrastructure. You're not worried about power, space, cooling, headcount, management. It could be a remote office location. Let us help you migrate that data in Azure such that it gives you two capabilities, which is the last bullet. One of them is disaster recovery. You can access that cloud snapshot from any other StorSimple solution in any part of the world and mount that cloud snapshot and restore, do granular restores from that. Or think about geo collaboration. The sort of development environments, generally they build out the infrastructure, they create sort of a binary, and they need to share it in EMEA or in APAC. They could overnight push it into cloud, basically Azure, and then the guys in EMEA or in APAC could download that copy. So the net summary are 4 components. Guaranteed performance because of the local capacity sitting within your data center. Auto archiving capabilities such that you don't need any archival storage or archival software to do any of that because it's native and the StorSimple software does that for you. Inbuilt backup and restore, which allows you to do granular restore. So now for the data set residing on StorSimple, I can truly eliminate my backup softwares out there, and then inbuilt disaster recovery capabilities because of the cloud snapshots we provide. So how do we do it, right? And which are the correct use cases to go after, per se, right? In the current environment, you're focusing your capital expense, your operating expense on primary. You are investing in future, right? My growth is going to be 10%, 15%. Let me buy that infrastructure. Let me buy that storage around that. The key IP for StorSimple is to figuring out what is the working set data. So if you look at big files, big archival, SharePoint, classic SharePoint is one of our key selling use cases. There is a concept of working set, right? All of us have used SharePoint, or most of us have used SharePoint. We upload a file or files, and we have never gone back and deleted, right? It is probably the storage admin or the application admin's headache to figure out how much storage they need to increase or implement so-called the archival project. The key value proposition now is the working set data, which a user or application will be using, will reside on that local capacity sitting in the data center, and everything else is now residing in Azure. So you are truly now, you could migrate into pay-as-you-go or what we call the utility-based payment modeling, and you don't need to worry about the growth because Azure provides us that expansion capability or the elasticity that is needed from a storage component. To answer the question earlier, right, on the cloud limitation, what does change in my infrastructure? The idea is zero disruption. There are multiple host site technologies where customer can migrate data from their current SAN onto sort of the StorSimple solution. The application server connects to StorSimple through iSCSI, Microsoft iSCSI Initiator, VMware iSCSI Initiator, present a volume or a LUN to the application server, and start migrating data. The key thing on this slide, which I want to highlight, is we have 2 tiers within the solution itself. There is a flash disk and there are SAS disk within the hardware component. So there is a tiering already inbuilt within the chassis framework. So data is always written on the flash tier, after which whatever components or the blocks move to the SAS tier, we do inline dedupe and compression. And that is how we present a larger working set to your application servers. So our local capacities could be 10 or 20 terabyte on that physical unit. But even if you see a 5x dedupe or compression ratio, depending on the application, that translates to 50 or 100 terabytes of local working set capacity. And that is how we guarantee that your working set will always reside on the local hardware, and we maintain the performance your user or application needs. At the back end, from the infrastructure, any data moving from StorSimple into Azure is encrypted using AES 256 encryption. Customer is holding the encryption key. We as Microsoft or Azure have no visibility into the encryption key, and all the data in transit and data at rest in Azure is encrypted, and it is all HTTP and HTTPS traffic. So it is using the WAN connection to migrate data back and forth, and that truly, if you think about the bandwidth requirements now, all the data migrating is dedupe and compress. So the bandwidth requirements are reduced, and at the same time, we only push incremental changes into Azure, and that way you don't need larger bandwidth sort of gig pipes to run this solution. So these are the 4 models that we currently have and are selling. And the 50, 20, and 70 model sort of have 2 terabyte and 4 terabyte local usable capacity. And the most common use case I've seen those being sold into is true archival. I'm trying to eliminate tape. I just want to move data, start migrating more data into Azure. Let me have a smaller unit which will basically dedupe, compress, and encrypt the data and have a copy stored in Azure. The larger 2 units, 5520 and 7520, are being used for tier 1 applications, like file share, archival, remote office can be now truly run on the StorSimple solution, because from a remote office standpoint, right, there's a virtual infrastructure in place. StorSimple could be the storage, which is providing archival, backup, restore, and DR capabilities. So from a customer standpoint, they could have a 1U virtualization layer and a 2U layer of StorSimple underneath that. So now they're just managing and maintaining 3U hardware in their remote offices, and that data is getting pushed into Azure through the cloud snapshot. So if they need to do consolidation or have that data available in headquarters, they could just mount the snapshot from these remote offices and have that data accessible in their headquarters. It's from a storage standpoint, right? Every customer I've spoken to needs thin provisioning, deduplication, compression, encryption, right? Truly enterprise class hardware. StorSimple has taken care of that, and the software does inline dedupe compression, as I said. All our volumes are thinly provisioned, and they could be expanded online. You don't have to take a volume offline, take it from 100 gigs to 1 terabyte. All that is truly an online task that the storage admin would be performing. And this is the true value proposition that comes in play, because Azure lets us allow the unlimited expansion or the elasticity that is needed. So there are tons of SAN storage out there which provide dedupe compression, which are doing post dedupe and compression while we do inline dedupe and compression. And the key benefit is the whole cloud data management that we let you do through this StorSimple solution. The dedupe and compression for us is across all volumes. So you could have one volume, a classic file share example I'm going to talk about, where customers have a file share for HR department, user home directories, engineering file shares. We find matching common blocks across that and then store a single instance of that in Azure via the cloud snapshot. So in this example, you could have 10 terabytes spread across multiple volumes, but you are going to be charged on the Azure side just for 2 terabytes because you saw 5x dedupe and compression, and through cloud snapshot, we only push those single instance blocks back into the Azure. The hardware manufacturer for Microsoft is a company called Zyratex. And as you can see, this is a truly enterprise class solution. The dual power supply, active passive controller, the SSDs and SAS are in its own RAID group. And we do have hot spares available. The most liked feature talking to our customers is the non-disruptive software upgrades. What we do is upgrade the passive controller when a new patch comes out through a web UI. When I do a demo, I'll show you. You go and upload the patch, and then we upgrade the passive controller. do automatic failover, and then upgrade the net new passive controller. So the entire transaction is non-disruptive from the user or application standpoint. And we have customers who have gone on a peak Monday morning, done upgrades on this solution around that. And we are the only vendor who is certified to run sort of Microsoft and VMware workloads on a truly cloud integrated storage category currently. So how does the tiering happen, and what is the magic behind it, right? We being an iSCSI SAN, when you migrate data onto StorSimple, what we are truly doing is we are converting that on the storage into blocks. We go and rank every block, a particular rank when it hits what we call as the flash tier. So your writes are always happening on the flash drives, and it gets a particular rank. As you push more and more data set, we start tiering older blocks into the next tier where inline deduplication starts happening, where we identify the common blocks and start giving you storage efficiency, storage savings right out of the gate. And this is why we claim that you can have, even though our local usable capacity, sometimes when I talk to media accounts of mine, they're like, you guys only have 10 or 20 terabytes of local usable capacity. But because of the inline dedupe and compression, we can hold much larger working set capacity by doing dedupe and compression at a block level. As you push more and more data set, we are going to be out of the flash capacity, and we start compressing older blocks on the SAS tier. So now the data sitting on, or the blocks residing on the SAS are fully dedupe and compressed, and hence the example of 5x, where it could translate to 50 terabytes of usable capacity. The way you want to think about this usable capacity is, if your change rate, your new data coming in, and your users modifying that data set on a daily or weekly basis fits that local usable capacity, you need not go and buy additional StorSimple solution, because Azure provides us the elasticity. The working set fits the local usable capacity, and everything that does not starts getting encrypted and gets pushed into Azure at that point. The key differentiation here is we are not a classic HSM or ILM solution, which are time-bound. Every 3 months or every 6 months, have not access a file, go push it into Azure. We are more capacity-driven. If there is 5 gigs worth of new data or 5 terabytes worth of new data, we will identify correspond or equivalent of matching blocks that are not being accessed and push it into Azure. When something becomes hot, something has to give away and become cold, and that is pushed into Azure. Now, on the cloud slide, there was sort of the concern on performance. So how do we eliminate the performance concern? We do have what we call as the metadata map, or what is the location of these blocks. Secondly, in this example, a file which a user is trying to access could be made up of blocks A, B, and E. Blocks A and B are also referenced by some other file which is hot at that point in time, so those blocks are already residing on the hardware. For whatever blocks which are remaining, we know the location, we go bubble those back up to the SSD and guarantee the performance. And so now your writes were always happening from the SSD linear, and your reads are also happening from the SSD flash tier, and that's how we sort of maintain the performance for the working set data. The amount of data pulled back is also incremental, and those blocks were also dedupe and compressed. Hence, the amount of time taken for us to fetch it from Azure and move it back onto the local storage and that's how we sort of mask out the latency at the end of the day. The key thing is from a user standpoint, all this is truly transparent. They are still going to their F drive, J drives, or wherever what the VMDK is, and this is happening at the back end, and it's truly transparent for them. So how do we do backup, restore, and DR, right? In the classic world, there's sort of classic NetApp, EMC, EqualLogic, left-hand compellence of the world. Each one has their own sort of snapshot technology, their own sort of replication where you do disk-to-disk replication, and then eventually NDMP dump into tape. So there's multiple layers around it. We have truly simplified saying we have local snapshot for your short-term recovery, which allows you to do granular recovery if you decide to. These are policy-based. You can manage and maintain through sort of those daily, weekly, monthly snapshots that you could take, mount them, and restore whatever data set you need to. They are residing on the hardware. And for the long-term data protection or for compliance reasons, we have what we call as the cloud snapshot technology, where the first push to Azure is like a full backup. And after that, only the change blocks, which are again dedupe and compress, get pushed into Azure. So the same block is now being referenced as a primary block, as an archival block, and as your backup in Azure. So in the architecture on top, customers are paying for the same block thrice the amount of money. For us, since we are a reference-based architecture, we could leverage the same block and deem it as archival, or deem it for the cloud snapshot technology, hence presenting the ROI from a storage standpoint to run your applications. Now, because of the cloud snapshot that you could take from your primary data center, that is visible as long as the identity of the appliance running in data center 1, we have ways to migrate it into any other StorSimple solution. They will have visibility to all the cloud snapshots within Azure. And then they can pick and choose one of those cloud snapshots and have that data available down in a different data center. So it need not be DR, it could be for geo collaboration purposes. So think about read-write happening in data center 1, and guys in data center 2 just need a read-only copy for some reason, for auditing purposes, data reporting, data analysis, whatever they want to do in a different data center, they could mount a read-only copy and have full access to the entire data set. This also lets all the customers test out DR on a quarterly basis or on a yearly basis. They could go and implement and try mounting or sort of walk through the DR scenarios, rather than learning the hard way that DR truly doesn't work when tsunamis of the world happen. How do we improve the performance of this disaster recovery versus the backup vendors out there and sort of restores done from tape? It is a 3-step transaction. One is importing the identity from data center 1 to data center 2. The second step we do, once you mount a cloud snapshot, is we only hydrate the metadata, or what we call as the block map. That lets us recreate the file system. And when the user clicks on a file or files, that is the third step, that we will only fetch those blocks and rebuild our working set. So if for a customer has 100 terabytes sitting in Azure, we don't wait for the entire 100 terabytes to come down and then we deem DR completed. We present the metadata for that 100 terabytes and let the user access what they need and rebuild their working set. And that is how our restore times based on the bandwidth provided. Here are some numbers that we can restore a terabyte down in 15 minutes, the metadata map, and then they can go ahead and fetch whatever is needed and rebuild their working set around that. Security, right? To summarize this slide, security is what I define in 4 steps in this case, right? First, we are converting your data set into blocks. And that way we are garbling so-called the entire data set. Secondly, we do inline dedupe and compression and randomize those blocks even further and garble it to sort of the second degree. Third, you as a customer are holding the encryption key. So any data leaving StorSimple solution going into Azure is fully encrypted and you are holding the encryption key. So, and fourth, Azure itself has what we call is the login and password around it. So if a user leaves or an admin leaves, you can truly change the access pattern at that tier and lock down any sort of harm that person could cause to your data set residing in Azure. So there are 4 levels of security, and we have now customers in medical, legal, financial verticals who have audited this solution and sort of certified them for sort of what they call is the class 2 data, and they are storing terabytes and terabytes of that data set through StorSimple in Azure. Here are some scenarios on what and how can we prevent, and these are classic questions that come up is, what if my access key is compromised? You can on a daily basis go to Azure and change your password. It's just like changing your password on your laptop. You have the capability of changing what we call is the secret key around that. The second scenario, the questions that have been asked is, what if my storage admin goes and decides to leave? What do I do in that case? Again, you have the key rotation mechanism, and you can change the secret key that is available out there. What happens if the drive is decommissioned by Azure? So there's a storage array we are decommissioning within the Azure data center, and if somebody gets hold of a drive, what happens, right? We basically do block level fingerprinting, and that data residing in Azure is encrypted using customer's encryption key, right? So even if they get hold of the drive, it's completely useless, and they cannot leverage any data out of that hard disk that they have got. Few case studies I want to talk about. So like I said, right, it's customers are looking at this as a true first step in, let me start migrating data into Azure, right? It is not replacing their current storage environment. We're not here to rip and replace everything that you have your current SAN. It is, let us identify that data set which fits this working set category, archival, file share, a smaller application not needing high performance throughput, migrated into this solution. So this customer has, being in semiconductor industry, tons of JPEGs, tons of PDF files. Their data growth was around 1.8 terabytes a month, and they were tired of pushing data into tapes, or their infrastructure was just hard to manage at that point. They looked at the StorSimple solution. They committed for their 600 terabytes of their entire data set is going through two StorSimple, the largest model, 7520, in the locations mentioned here, onto Azure. And it's a single file share that they have presented to their users through our application server. So all this is happening at the back end, truly transparent, but the benefits they are getting is archival, backup, restore, and DR down to a single file level through a single console, which I'll show you in some time. And at the same time, they went and invested in a disaster DR unit also. We do have PowerShell scripts that can automate the entire DR scenario. So you can mount the metadata and keep it ready on the Phoenix side of the house, such that all you're doing is sort of AD DNS updates and redirecting users, and then they will be able to see their metadata information and access the file they need to on the DR side if they want to. Fortune 500 customer, and this is where I'm going to talk a bit about SharePoint, because we do have plugins which allows you to do blob separation. So Microsoft had these APIs that you could build, and they call the EBS and the RBS, which lets you do the blob separation. The net summary is, when a user uploads a file on the SharePoint farm, the metadata gets committed to the database, while the actual content, which now could reside on a blob store, and that blob store could be a volume coming from StorSimple. Since the data is not committed in the SQL database, it lets you, because of the inline dedupe and compression, they get storage savings on that blob store, which could now, in this customer's example, they are up to 400 terabytes and growing. So they are seeing tremendous dedupe and compression, because it's sort of, at the end of the day, it's all Office documents, and they are able to see large dedupe around that. Their SQL database size has shrunk by 95%. So now the SQL, they were doing SQL DB mirroring, and they're able to reduce the number of databases that they manage. Now, currently, they're down to, I believe, 40 databases only. And third is the restore process is now they can go and restore down to an individual item level restore by just mounting a local snapshot or a cloud-based snapshot, depending on the retention that they have identified. So a single, and this is the lower end model also. It's the 70/20 model acting as a file share, because for their around 400 terabytes of data set, there is really a small amount of working set that they had. Hence, they could sustain the performance just on a lower end unit for their. The other architectures that are coming, talking to media, legal, and financial verticals, they have a lot of these remote offices. And they truly need DR or backup components around that. They're done paying licenses for their backup softwares, or they want to reduce the infrastructure footprint. So in this example, what I'm showing is customers have StorSimple in every location. Through DFSR, gets replicated to their central site, and then they do cloud snapshot from a central site which has sufficient bandwidth, like 40 megabits per second or so, that they can provide. Some customers are leveraging their existing storage. They have DAS storage, or some of them have gone and implemented Windows Server 2012 in these remote locations and then leverage DFSR to get the data to a single StorSimple, and that acts as their backup and DR software, and gives them all the capabilities that they would expect from their backup software or the tape vendor to back up this data set. Media verticals, this is where things start getting interesting, and the whole geo collaboration or sharing the data with your partners, right? You could have customers work with their own partners. Think about the media industry. A movie gets created, they back it up into Azure, and then through any other StorSimple solution in their remote sites where they could be doing transformation, encoding, or just changing the language, right? English movie getting converted to German language or Indian language. Their remote locations could just mount that true master copy, do the edits on the cloud snapshot, and then store it back in Azure. So the master copy is still intact, while they can start creating multiple versions of that and store it at the cheapest price point out back in the Azure. And this is where the whole sort of the content distribution and the CDN in the media vertical is where they're looking at leveraging StorSimple with the capabilities of Azure at the back end. With that, let me jump into a quick demo. What I'm going to show you is the simplicity of configuring the appliance, how easy it is to configure, how easy it is to map a volume to your application server, and then go through the whole backup, restore, and DR components of that. Okay. So through a serial console, right, the configuration of the appliance is pretty straightforward. Is through serial console, you give it a management IP address, and then you can manage this through a web browser. Once you log into the appliance, there are just 3 basic tabs. One is the one-time configuration, then daily management, and third is reporting around it. So there are 3 key steps that is needed to configure the StorSimple solution, right? The first one is what we call networking. What interface do I want to connect to my application server, and what interface I want to go through my WAN such that I can reach the Azure data center. And what the functionality we give is you can decide if both the interfaces are going to have the incoming outgoing traffic, or you can separate it in different VLAN if you decide to. DNS server, because all the traffic going, like I said, is HTTPS traffic at the backend from StorSimple to Azure is all HTTPS traffic, so DNS server for that. And then NTP, when you're mounting the cloud snapshot, we ensure we pull down the right data set from Azure at that point. We do support all forms of iSCSI authentication mechanism. So you can see CHAP, we do have access control records. And this is, access control records is basically saying volume A can only be seen by server A for unnecessary writes and deletes, right? So you can lock it down at that level. Or you can use CHAP and say only initiator with this login and password can connect to the StorSimple appliance, after which they'll be able to see the volume. So there are tons of ways you can have a granular control on which server, which iSCSI, or which user goes and connects to the solution. We do have all forms of alerting. So there are alerts which can be sent to your storage admin team, or it can be sent directly to the Microsoft support. So what we call is the proactive support. So if there's a drive failure or a controller reboot, we can be proactive, reach out, say, we have seen this alert come in, do you need any help to go ahead and fix or rip and replace it? The second key step is now let us help you bring Azure to your data center, right? So all you're doing is through the Azure portal, now you can cut and paste what I was talking about is the secret key and the access key, right? Nothing but your login and password to this blob storage that you are paying for in Azure. Once you do that, we go and hit verify. This storage account now could be mapped to any of those 8 data centers. So from here, what we are doing is we are ensuring we can reach that data center. It could be in Hong Kong, Singapore, or the EMEA locations or the US base, and ensure you have cut and pasted the key properly. We can reach the data center and the NTP server is in time sync. You can have 64 of these cloud accounts configured through a single StorSimple appliance. So a lot of these, couple of our customers have what we call is the chargeback mechanism. They create sort of HR cloud account, they create finance cloud account, engineering cloud account, and at the end of the day, at end of the month, they just take the Azure billing and charge it to the department and do chargeback. So it's fully automated. They can actually plug in the department's ID in the Azure portal, so it's all automated and they can go audit it whenever they need to. The second step is what we call is the configuration. This is where they could go and say, I need to create a configuration, and this is where they enter their security key. So just the configuration, the key component of configuration is what is the encryption key. They could leverage their key management system or enter a 32-bit passphrase, and that will be leveraged to encrypt any data leaving Azure and going to leaving StorSimple going to Azure. So now the final step is the best question I ask before I do the demo is how much time would it take to actually go and back up 100 terabytes, create a 100 terabyte volume and go and back it up to any of the storage admin, right? Is now I go click on create a volume. I want to say Jai demo, and then pick and choose what we call is the type of volume or the data set that you're going to store. The reason for type of a volume, so that I'm going to go to custom volume so I can talk about it a bit more, is there is what we call is the priority association at the back end, depending on the type of volume you select. Sorry about that. So there is a normal priority. It would go through the entire animation that I showed you, SSD to SAS to Azure. The local preferred gets tagged saying, hold on to this data onto the storage as long as you can, after which go and tier it. So it's a preferential treatment. It's not a guaranteed local only at this point, right? And what will happen is I have 3 normal volumes and 1 local preferred volumes. Then those normal volumes will tier into Azure much before the local preferred will be touched upon. So think about SharePoint transaction logs or virtual machine guest OS images, right? You're going to power on, power off those virtual machines, or the transaction logs are going to get committed to the database eventually. For that, the local preferred volumes definitely does. That's why it was sort of created and implemented. For media customers who are doing true archival, they can go and change the block size, right? They can increase larger block size because it's true archival. They just need some storage space in Azure, and then they can control the block size on how fast they want to write into Azure. With that, I could now map it to a particular configuration, right? A cloud account mapped to one of the data centers or the cloud account. And then I could thinly provision a 100 terabyte volume and say enable monitoring for that. And with this right click, it automatically creates a policy saying every night, dedupe, compress the data set, encrypt it, and push it into Azure. So with 3 clicks, now I'm able to provision a 100 terabyte volume and let it grow as needed from my application server side. And from a granular control, I could now say only present this volume to this demo server of mine. That way, it has no other no other server can do unnecessary writes and deletes around that. On my application server, I am connected to the StorSimple device through the Microsoft iSCSI initiator. So now if I go to my disk manager, here is my 100 terabyte volume available with 3 clicks. And if I convert it to GPT, it will let me, here's my 100, create a file system on top of NTFS file system on top of it. It could be a Linux initiator, create a mount point, NFS mount point, and give it to the application server. In interest of time, I have this 5 gig volume ready to go, which is nothing but, let me just show you on the web UI, is this MMS demo that I have. And what I've done is added some files on that just from a local file share perspective. So all this data, since it has not exceeded the local usable capacity, is coming from the flash tier or the SAS tier, right? So that's why all the users get the file share performance that they need to see. Now, how do I do data sort of the backup restore, all right? We have this MMC plugin, which allows us to leverage the VSS components and take application consistent snapshot. So we didn't go with fancy sort of management tools, just MMC plugin. Most of the Windows admins are used to it, and hence the MMC route. If it's a non-Windows based application, you can perform the same tasks through the same web UI. So you need not be going back and forth between web UIs. The other thing to note is, if the configuration was done through the MMC, we auto import all that information in the web UI within 30 minutes. So all that will be available on the web UI, so that you don't need to log into every application server. If you decide to, you'll be able to control everything from the web UI. So the first step is to go and what we call is create a volume group. The reason for volume group is you could have 10 file shares and you want to apply a single similar policy for backup criteria. Or it could be a database volume, a log volume, to ensure VSS knows which volume to queue. It's sort of the consistency group that you go ahead and create. Once that is done, I could now take a backup, which is nothing but local snapshot residing on the hardware. Or I could go ahead and in a similar fashion take cloud snapshot. So even though my appliance is not full, this is the mechanism where I can ensure that I have a truly independent copy now residing in Azure. For DR purposes, for data protection, long-term compliance, this will dedupe, compress, encrypt the data set, and will now be available in Azure in a couple of minutes. Right. I didn't highlight Cloud Clone, to be honest, because I have only 2 customers using it. It is identical to the Cloud Clone, but the destination target is completely different. So for a given volume, you could say Cloud Snap is going to my West Coast Azure data center, and the Cloud Clone could go to my Hong Kong data center. Some customers of mine have this legal compliance that they truly have to show it's residing in a different data center, and that's sort of where the Cloud Clone truly comes in play. Azure does a 3-way replication, the geo replication that I talked about earlier on. Because of that, that's been sufficient for most of the customers, and they have not gone and enabled Cloud Clone. The thing I'd mention about Cloud Clone is, think about that you are doing disk-to-disk replication and moving the data to tapes. You are paying a tape vendor double the cost for the same data set. You are going to pay twice the amount to Azure because now you're maintaining same copy in 2 different data centers, and that's just the full disclosure around it, and not all customers have gone and enabled it around that. One, you do have sort of the status on completed jobs, on the speeds and feeds, or that everything around it, or the jobs that are running currently. You can see the status on the speeds depending on the bandwidth that is being provided, right? Once the backup is completed, I will be able to see those date and time stamp snapshot or cloud snapshots available within the MMC plugin. So let's say a user goes and deletes the entire data set, or some of his files go missing, right? the storage admin, and we could also enable the previous versions on the host side, right? It's the Windows capability. If the user needs to do the restore, admins can go and enable that. Or you could right-click and do volume level restore. We know it was mapped to E drive, and we will hydrate the metadata information for that for the data set at that particular point in time onto the E drive. Or for volume level restore, you could go ahead and do what we call, I'm going to say snapshot clone, and map it to a different drive letter. In this case, I'm going to say J drive. Same workflow applies for the cloud snapshot. I could do volume level restore, or I could go and do volume level restore, or I could go and clone it, and I'm going to clone it and say restore from cloud snapshot and map it to K drive in this case. What happens in this case is for the cloud snapshot piece, we just go and hydrate the metadata information. But on a volume side, what we do is we present 2 new volumes. So think about now if there's a legal lawsuit and you need to hand out a data set. You can quickly use this cloning feature, which I'm showing for restore purposes, but here in this case, I see 2 new volumes created, the StorSimple clone volume. I could change and present it to a different application server and give it to my legal department and say, here is the data you requested 6 months ago or 3 months ago. Once you're done, let me know, and I can go and delete that entire volume out of it. So hence the reason we went with this whole cloning route that allows you to even think about upgrades. I'm doing some sort of upgrade or a binary development, and I can quickly create clones of the entire data set, test out my upgrade on that, and then get rid of the volume once I'm done with it. So if I go back to my file explorer, here is K drive, which is coming, I forgot which was which, but one is snapshot, the other is cloud snapshot, as you can see. And I can drag and drop some files from here and some files from here and move it back to my primary volume and be done. Yeah, copy and replace, yeah. So that's how you can do granular restores if needed on this, through this. And once that task is completed, I'm able to see those volumes available here, and I can go delete once I'm done with the restore. Okay? So that was how sort of the whole primary auto-archiving works and then backup restore. From a DR standpoint, right, how simple it is the slide I was showing of 3 steps, right? The first step is on my primary appliance. I would go and what we call is save the identity of the appliance. It's an encrypted file. Only any other StorSimple appliance will be able to read this. So I download it, save it on my management server, or it can be emailed out to your accounts if you decide to, and save a copy there. On my DR appliance, I would go and import the same configuration file. What this tells me is what is my encryption key and the login password to that sort of the blob storage, the Azure blob storage that I have been taking cloud snapshots into. Once that import is completed, which is a single click, I could go under cloud credentials, and on my DR appliance, I will see this same cloud account created, except I'll have it imported in brackets on my DR appliance. And this key, this click is the most important click. This will go to that bucket and find out how many cloud snapshots I have. So it could be 50 cloud snapshots or 100, depending on the retention I have defined through my policy. And I will be able to see all those cloud snapshots. And then I would perform the same task to go ahead and restore it just like I did. So DR truly becomes a 3-step process of export, import the identity, download the registry, which is just a simple file, shows us number of cloud snapshots available, and then do the restore process as I just showed you. Most of our customers have gone with the active route and not go with a dedicated DR unit, just like the Arizona example I was showing, because each one could be running their independent primary file shares, and when time comes, they could act as the DR unit for the other location, because all we are doing is metadata management, and that is what we would go and hydrate. One thing I didn't mention, which I'm sure some of you might be thinking, we do have a policy engine which I spoke about, where I can pick the snapshot type, the retention, and the schedule that I want to go ahead and create around it. So it can be automated and through policy-based, just like your traditional storage would provide, you have those capabilities. And the software upgrade, which I was mentioning when I was showing you the enterprise class hardware, it's truly a single click upgrade. You browse the package, you download from FTP, click upgrade, we do some validation checks, and the validation checks are truly saying, do you have a cloud snapshot available? That's all the validation is doing, and then you go and click start upgrade, and it's a fully automated process and truly transparent to your user or application. From a reporting standpoint, this is the most liked report, right? Cost savings it lets you compare your traditional storage cost for the same data set to a StorSimple and Azure cost matrix around. So you punch in the numbers, it picks up the dedupe ratio automatically from the hardware, depending on the storage savings that we have provided, and gives you the ROI chart that you are saving by moving your data set onto the solution. So you could just print it, take it to a meeting in case you're doing some ROI, cost analysis, budgeting, really handy from that standpoint. And three classic categories, which is capacity at each tier, performance that I'm getting, and you can drill down to individual NIC, individual volume if you decide to. So there are granular reports available around it. And then system. How is the system itself behaving from a network latency throughput perspective? And finally, in case there's support or sort of you need to file a case, under support, all you need to do is create packages. We gather all the information we need from the storage and create a zip file. You download this and move it to our FTP site, and that's all you need to do during a support case, right? We don't want to spend long sessions on link or sort of help you get to the root cause much faster. So we have sort of taken care of all the support files that we need around it. And the last thing that I wanted to highlight is you can do the hardware management directly from the web UI, right? So if you want to see the status of every component on the storage array, right? This is, we put a picture in it, so when we are doing the initial install, we sort of we do most of them through a remote install. We can guide the admins through what needs to be plugged where, the back and front of the chassis, and then you can drill down into every controller health, drive health, or sensor, NVRAM, everything at a controller level. So if you want to identify which was the active controller or passive controller, you have all the granular details available about the health of the hardware from this screen. So with that, I'll leave 15 minutes for Q&A. Hence the name Simple, StorSimple, so I can finish it fast.
Hi, this is Patrick. You showed in the configuration of the volumes several application types, right? But it was so fast we couldn't see it. So what data is good for storing on StorSimple and what not? So I can imagine file services and backup as well, but what are the other ones?
So we stay away from high performance, think about OLTP transactions or high-end SQL databases. If you go back to my animation slide, right, my storage is full, my data is steering into Azure. If I do a massive query, which is going to read tons of data back into SSD, so every read could cause 2 writes to happen. And depending on that point, the bandwidth could be critical, or depending on how much data becomes hot at one given time. As long as those massive queries don't, you could run smaller databases, non-IO intensive databases, tier 1 file shares. We have every customer of mine running tier 1 file share. Archival, no brainer, because it's write once, read probably 5% of the time. All those use cases are a perfect fit for this solution.
Okay. And you mentioned that both virtualization vendors, Microsoft and the other one, are certified. So I can hardly imagine that I will put my VHDs on StorSimple. Does that make sense to you?
So that's where the remote office use case comes, and I'll give you two scenarios where customers are using remote office, right? You could have all your Hyper-V guests, because those are file, serve, print, AD, DNS out there in remote offices which are non-critical. So then those could run on StorSimple. We could be the backup DR archival tier for that. The other use case has been what we call as the VM sprawl in the test dev environments. Engineers like us go create virtual machines, they never delete it, right? So all the expensive SAN is getting utilized for virtual machines which are just sitting there, probably not used for 30 to 60 days. We have few customers, what they call is the VM sprawl use case. They start migrating those virtual machines through whatever orchestration tool they have, figure out which are not being used, they move it to StorSimple and back it up into Azure. And they define a retention for 60 days or 90 days, after which the VM's deleted. If the help desk ticket comes in, they could power it on StorSimple because it has enough local capacity and it gives them the performance they need. So that's the use cases I've seen. Or think about file share running within Hyper-V. That could be because the I/O is still the working set concept, and we'll dedupe and compress and give the benefits from that front.
Okay, and one more question. When can we expect a management pack for operations manager?
There were tons of roadmap questions which I knew would come, and so everything is in works, and I'm sure you will see a roadmap update slide coming out pretty soon. Okay, there's a couple of things just because of the whole ecosystem, the partner ecosystem. We just want to see what makes sense to do and what doesn't make sense to do.
Okay, thank you.
Yeah. Cool. We can go for beer 30 minutes early. Cool. Thank you, guys.